Some people are missing. Shh. Yeah, I will. Start copying this down, please. Yeah. I can. What are you doing? What's wrong with the calculator you have in your hand? Bring it to me. And you didn't ever have to walk around all the way that way. I'm not stupid. You do realize that. Sit down. And it does turn on. So hit the on button. Good. 1 for you. Okay, so when we talked about proportional relationships, what makes something proportional versus not proportional, we talked about how if something is proportional, then that means they will have equal unit rates. If something is proportional, it will have an equal unit rate. So when we took our test yesterday, was anybody absent yesterday for the test? Just Taylor, right? Everybody was here. Okay, so yesterday, one of the questions that you guys, a lot of you messed up on, was the question that wanted to know whether $4 for 6 cans was proportional to $10 for 18 cans. And quite a few people got them wrong because you couldn't, one, you didn't know that it was not proportional, and 2, you couldn't even identify why it wasn't proportional. But we stated before that they have to have equivalent unit rates, that in their simplest form, their rates should be the same. So if I set them up as ratios, so $4 for 6 cans, if I set it up as 4 over 6, well, 4 over 6, because it's $4, when I simplify it, it comes out to about 67 cents per can. That's the unit rate. It'd be 0.6 repeated, but I'd have to estimate it or round it to the nearest penny. And then when I do the same thing for the $10 of 18 cans, and I simplify that, it's going to come out to about 56 cents per can. So obviously these two values are not proportional to each other because their unit rates are not the same. So it's a non-proportional relationship. But there are actually other avenues that you could take to being able to identify whether something is proportional or not proportional when they're set up as ratios. So we could have taken those same two ratios, that 4 over 6 and that 10 over 18, and we could have done the cross product. If it's proportional, we should check for equal cross products. What do I mean by cross products? What am I doing? Camry? Cross multiplying, right? You're multiplying the diagonal values and seeing if they would be equal to each other. So I would multiply 6 times 10, and what is 6 times 10? 60. And then I would multiply 4 times 18, and what's 4 times 18? 72. And then I would check them. Are they equal? No. These are not equal to each other, so that also indicates why it is non-proportional. Okay, so in order for it to be proportional, not only do you have to check the unit rate, or that's one method, would be to check the unit rate, but another method would be to just do the cross product and see if you get equivalent values from your cross product. So what I want you guys to do is for these next 4 problems, I want you to use the cross product method to tell me whether or not these ratios are proportional to each other. So if we have 5/8 and 2/3, use the cross product and tell me if they're proportional. Number 2 is 7/3 and 14/6. Number 3, you'll have 6/8 compared to 15/20. And then number 4, we've got 16/9 compared to 11/6. So use the cross product and identify if they're going to be proportional or not. All right, Glenn, number 1, is it proportional or not proportional? Very good, non-proportional. So if we do our cross product, if we multiply 8 times 2, God bless you, 8 times 2 is going to give us 16. And then if we multiply 5 and 3 together, 5 times 3 is going to give us 15. Well, those are not equal measurements. 16 and 15 are not equal to each other, so this is going to be non-proportional. Okay, what about problem number 2? Who can tell me number 2? Kalia. Proportional, very good. Again, if you multiply, if we do 3 times 14, 3 times 14 is going to give us 42. And then if we do 7 times 6, 7 times 6 is also going to give us 42. So those values are considered to be equal to each other. Therefore, it is a proportional relationship. What about problem number 3? Cameron? Proportional. Okay, 8 times 15 is going to give you 120. So is 6 times 20. 6 times 20 is going to give you 120. So those are equal to each other. It is proportional. And then what about the last one? Jonathan? Non-proportional. 9 times 11 is going to give you 99. And then 16 times 6 is going to give you 96. And of course, those values are not equal to each other, so therefore it is non-proportional. Any questions about how to use the cross product? So easy, very, very simple stuff. Now, obviously, based off of what we titled today's material, we're not necessarily just checking for proportionality. We're going to use the cross product to solve for proportional relationships. Because if we know the cross products have to be equal, if one of those values happens to be missing, then we could use the cross product to solve it. So let's say that 15 was missing. Let's say it was 6/8 and x over 20. Well, then we would know we would do 8 times x instead of 8 times 15, and we'd have 6 times 20, which is 120, and then we would just solve that equation. So that's what we're going to be doing next. Given proportions, we need to solve for the value that will make that relationship proportional. So we're going to solve each of the following proportions. So if we've got 11 over x is equal to 100 over 11. The first thing that I'm going to do is I'm going to perform or use the cross products to create an equation. And it's just going to be a one-step equation. Always the same step as well. So we're going to multiply our variable times the number that it's diagonal to. So that means x times 100 is 100x. Very good, Ariana. So you're going to get 100x. And then, of course, we're going to multiply 11 times 11. And what's 11 times 11? 121. So now we have an equation. 100x equals 121. So this last step to solve it, it'll always be the same exact step. You will always divide to solve. And what are we going to divide by? 100. Is it always going to be a 100 that we divide by? No, it's whatever the coefficient is, whatever value is paired up with our variable, that's the value that we're going to divide by. So in this case, it just happens to be that we're dividing by a 100. And then we get our value. X is equal to 1.21, and you're done. Okay, I want you guys to try these ones on your own. All right, who can raise their hand and tell me what they got for problem number 2? Annabelle? Well, we're solving for y. We need to know what y is going to equal in order to make it proportional. Anthony? Y equals 3. So if we do the cross product, if we do 12 times the y, that's going to give us 12y. And if we do 4 times 9, that's going to give you 36, and then you would divide both sides by 12, and that would give you y is equal to 3. Okay, what about for problem number 3? What does y have to equal for that? W equal. Layla? W equals 16. Very good. So we're going to do 5 times the w to get 5w. Then we're going to do 10 times the 8, and that'll give us 80. And then we will divide both sides by 5, and we'll get w is equal to 16. Okay, what about for problem number 4? Jonathan? K is equal to 1.8. Very good. So we do 7 times k. 7 times k gives you 7k. And then you're going to do 3 times 4.2. And that's going to give you 12.6. And then the last step is to divide by 7. And that's when you get k is equal to 1.8. What about problem number 5? What is x going to equal for problem number 5? Rachel? 3.6 is correct, yes. So we have 5 times x, which is 5x. Then you've got 2 times the 9, which is 18. And then you'll divide both sides by 5 and get that x is equal to 3.6. Any questions about this, guys? It's pretty simple, straightforward. Now, the part that's probably more difficult is having to set this up. So if they give you a word problem and you have to create the proportion to solve. So that's what you're going to be practicing, because obviously when it comes down to a final exam, you know that's the kind of questions that they're actually going to ask, is where they'll give you a word problem and then you're going to have to set it up. So that's what we're going to practice right now, and that's what most of your homework is going to be based off of. You'll have a few problems that are already set up for you to solve, just like this one is. I think about 6 or is it 9? I think it's like 9 problems maybe to do that way. And then the remainder of it is going to be word problems where you set up the proportion based off of the word problem and then solve it. If you don't set the proportion up correctly, then it doesn't matter how you solve, you'll get it wrong. Okay? So let's take a look at a couple of examples of some word problems to do. We're just going to do 2 examples, so that way you have some time to work on your assignment. But you're going to want to make sure that you copy this down. It says a 12-ounce bottle of shampoo lasts 16 weeks. We want to know how long should an 18-ounce last. So how long is an 18-ounce bottle going to last? So in a situation like this, we need to set up the ratios based off of 2 things. The first ratio is the information that they are giving to us, information that we already know. The second ratio is going to be information involving the question, what values are currently missing. So right here, the information that they actually are giving to us is this part, the 12-ounce bottle of shampoo that lasts us 16 weeks. Okay, so this, I'm going to label this the stuff that we've been given. The question is how long, or how many weeks should an 18-ounce bottle last us? That's going to be set up as the information for the question. So the first thing we want to do is what I highlighted in orange, the given. We're going to want to create a ratio, a fraction. It does not matter how we set that part up. We could do 12 ounces over 16 weeks, or we could do 16 weeks over 12 ounces. It really doesn't matter. I'm going to go ahead and just do 12 ounces over 16 weeks. So based off of how I set this one up, though, will determine how I have to set the question up. So I want to know how long should an 18-ounce bottle last. So they're giving me 18 ounces. Where does the 18 ounces have to go when I set up this ratio? On the top, because I put ounces on the top to begin with. You remember? So we talked about this previously. Since I put 12 ounces on top, I had to put 18 ounces on top. Since I put 16 weeks on the bottom, I have to put what for weeks? X. Very good. So we have to put X weeks on the bottom. And now we can set this up and perform our cross product. So we're going to multiply the variable times 12. So we get 12x. Then we're going to multiply 16 times 18. Gives us 288. And then we're going to divide by 12. And how many weeks will it last? 24. Very good. So we get 24 weeks that the 18-ounce bottle will last you. Yeah. Not at this time. You gotta wait. All right, I want you to copy this one, and you're going to do this question on your own. So a neighborhood has 13 brick homes out of 20 on one street. If the neighborhood has 60 total homes, how many of them are brick? Okay, I want you guys to go ahead and get that written down and then set it up and solve. Oh, okay. So what did you get? Very good. 39 brick homes. So the information that was given to us is that the neighborhood has 13 brick homes out of 20. So that means our given is 13 brick out of 20 total. Right? 13 brick homes out of 20 total homes on that street. The information that we want to know is how many of the homes are going to be brick if there are 60 total homes. So we want X brick out of 60 total. X brick out of 60 total homes. So we've set that up, and now we can do that cross product. So we can do 20 times X, which will give you 20X. And then we can do 13 times 60, gives you 780. And then you, yep, very good. You divide both sides by 20, and you get that X is going to be equal to 39 brick homes. Now notice, sometimes the variable, like in this question, the variable was on top. Sometimes the variable might be on the bottom. It just depends on how you set the original ratio up. That'll determine where you are going to put your variable. But as long as you set them up correctly and then do the cross product, you should be fine. Any questions? Cameron?
Are you equal? So for instance, if you did 20 times 60 and then you did 13 times x, would it still be the same?
No, it would not.
Because it would be 2 decimals.
Yeah, 20 times the 60, that's going to give you 1,200. And then 1,200 divided by 13 is definitely not 39. 92 point something, okay? So the way that you multiply and the way you set it up matters. It doesn't matter how you set the first one up. If I did 20 over 13, then I would have to do this one as 60 over x. So how you set up your question is determined by how you set up your given. Okay? All right, so let me go ahead and get you your worksheet. You're going to complete the worksheets due Monday.